Welcome to AI in Reality. I'm your host, Fred Ware, and I will explain and illustrate how to implement the androids in this Netflix movie Subservience using today's AI technologies.
The most sophisticated AI on the planet, and these models are specifically designed for mimicking human emotion.
A key phrase in that scene is human emotions. So to implement an android like that, it will need the ability to project and receive human emotions to interact naturally with people. Before I get started talking technology, I was telling a friend how sophisticated and complex an AI system would have to be to make an android like that. And she asked, why would anyone implement an android when they can interact and talk with real people? My first thought was, I don't know. My next thought was, I believe all people have some common thoughts and characteristics, but at the same time, we also have unique qualities and interests. So perhaps an android can help free up time for you to be more productive in general. You pick the area of your life you want to grow in, and the AI community will work to build something to help you. Nevertheless, I'm an AI technologist. I like creating smart solutions and new applications. So let's talk about it and have some fun. Okay, in this section, I'm going to discuss how the vision of the android can work. I'm starting with a demonstration of object detection, which is a main feature of a vision AI system. And in this scene, this clip, I have running on a loop and I slowed it down. You're seeing what one camera can accomplish by identifying objects. Here, it can identify the chairs, the table, the persons, the cup. And this is what each eye that the android Alice would have at her disposal in order to identify objects, in order to respond. And also, in addition to identifying just the object, you can also know the distance that object is from the android using the offset between identifying the same object in both eyes. It calculates an offset called displacement, and from the displacement you can calculate distance. And now I will discuss a full vision system in the following diagram. Here, you're looking at the full vision for the android. It's not a comprehensive system, but it is pretty sound for standard functions that the android will need to perform to emulate human vision. Okay, starting from the left, here you have the eyeballs, which are the cameras will reside there, and they're high quality, high speed cameras. And those frames are coming in, I'm calling them cam left, cam right, into a camera manager. Camera manager will disperse those frames to various algorithms that need to run simultaneously or in parallel. And so here up top, if you take the top path, this is the object detection path. And there are two independent paths that are performing the same function, but just on different streams. So you would detect the object quickly. So you have a real-time object detector. You get some standard objects, person, cup, toy, etc. Then you would go through and you would perform a higher detail object detection. Be a little slower, but it'll be higher accuracy, and obviously it has more capacity for more objects, right? And also I embedded a gender predictor in there. So here you're outputting man, baby boy, young girl. You can the toy, the actual toy itself, kitchen bar chair. Those are the type of examples of the output that will come. Then you can collect that data in a common object merger, get your final result, and save it to a table in your database, which would reside inside the Android. So it's in real time, constantly updating this table. At the same time, you would want to recognize the faces that you detect. So you will pass your frames and perform face recognition. Once you detect that that there's a face there. And then in that case, you would also, to do that, I should say, you would generate what's called a face embedding. This is one approach to face recognition, face identification. And so the face embedding is a mathematical representation of a face. So every time you have a face, you pass it through here, you can test it against a face embedding that you've saved earlier to see if you are identifying the same face. And now you have a higher level of detail of the persons, which you would update in the exact same table. Next, you will identify the emotions of the people you detected, and you can train a motion predictor, which is the block I have here, and you can get some high-level motions. Obviously, you can do it to whatever level you want, but emotions like neutral, sad, angry, frustrated, happy, those type of emotions will play a role to help the android react to the people in its scene or in its environment. One last block in this diagram is gaze controller. And here is where if the android is focusing on an object and that object moves, such as the cup falling from the table, then this information will provide the ability to get the direction, or I should say vector, in terms of where that object is going. And therefore, in order to stay centered and stay focused on that object, you can pass that type of direction information to the vision system for the actual eyeballs, which will reside in some casing and allow some freedom of movement around its centroid. So here is a standard approach for vision for the android. It should mimic the human being in that you only have two eyes in front of you, and so there you have the same level of constraints that a human would have. You can move appropriately. Next, I will discuss audio and text for the android.
Do you need anything, Nick?
Do you know what the parameters are for an FAA to stop air traffic?
In adverse weather conditions such as snow or ice, sustained winds of over 55 miles
That
an
was
hour.
rhetorical.
Of course.
Yeah.
Okay, the clip that I'm showing is a scene where Nick and Alice are having a conversation. And here's where I want to show how Alice, the android, can consume audio, process it to generate information that allows her to interact like a human and with humans. The main functions that are occurring here that I'm pointing out are the dialogue exchange, which is conversational AI, can be handled by conversational AI, and emotions, which can design a model, a machine learning model that can predict the emotions from the audio. So let me show a diagram of the audio system. Here's a diagram showing the data flow and the processing for the audio of the android. Again, this is not comprehensive, but it is solid at providing the main results from the audio that the android can consume and react to. Starting on the left, you have the icons representing the left and right ears, which are where the mics would be, which is similar to where the humans will receive that information, the audio information. And then you have an audio manager, and that will pass along the audio data to the various processing algorithms that are running in parallel. So if you start at the bottom, you have two independent pipelines for executing the conversational AI. You have the information, the audio that comes in for speech to text conversion. Then that text information is passed to the prompt creator, which will generate a proper prompt input for the chat completion, where you would generate the response based off the long language model designed for this system. And you would have the result from both streams, which you can combine to produce the optimum result that you want to save into the table. And that can be saved in the same table as the vision information. And this will represent the recent information that Alice would always use to respond in real time. So here I have an example of the chat response in the far column, and an example where you may want to keep only the latest 4 exchanges between the various people Alice is communicating with. And it'd be a sliding window. Also is to point out that you can use that information along to help produce your latest prompt information for the present. So you take the past exchange along with the current present text, and that would generate the prompt necessary for the next output in that conversation. Also on the top, you will have, I'm showing where you would independently predict the audio that you're hearing for the emotions of the human that the android is interacting with. So here you have your left side and your right side. You get the result, the emotions, and then you can merge that result and produce the right or the best outcome that you were able to infer into the exact same table. And so those emotions can follow in the same vein as the video side. So I package them that way. So this is an example of an audio system for the Android. Next, I will talk about the intelligence center of the Android.
Go play on the slide.
But I want to go on the seesaw!
Your child woke mine. Perhaps you can take him somewhere else.
I'm instructed to stay until 4. It's only 3:34.
Okay, the clip I'm showing is a dialogue exchange between 2 androids, Alice, the main character, being one of them. And it's also to show the various predictions and detections that are occurring from the vision, both the vision and the audio sources that can be consumed and utilized by the androids to interact and amongst humans. So now I'm going to talk about the intelligence center of the android. So here I am showing a block of the activities that can occur in an android to allow it to be more productive and perform more optimal. And so on the right, you see a list of records, right? Basically illustrating the table that it uses for its regular activity of keeping current, up to date of what's happening in the current time. Perhaps you have a history of it. And now over on the right is a block that shows what can occur in the Android in terms of background and offline activities. And so starting with calibration, and I want to just show a quick diagram of what I mean by calibration. So here is where the Android in this scene walks into the room and stands still and scans the room. This is reminds me of a technique that we use when we want to calibrate our cameras. I'm sure this is something that you can do in other areas as well. So you're able to identify, she's able to mark herself and reference herself in context of everything around her. And that's something that is can be done repeatedly for various environments in all sources of data to allow the optimum ability to get the best fidelity in terms of your range of the sensors that are in her, in terms of the mics and the camera lenses, in this particular example. Now, also that's possible is to take the historical data and perform some analysis on the activities and how well did they go and how well did they not, and where did you make mistakes. And so I have a bullet item here in terms of doing analysis in the last hour, doing an analysis in the last day, 24 hours to 1 day, 7 days to which is 1 week, 30 days, which is represents 1 month, right? So those are just like example times that you can do it. And I just call it a dream mode. And that's just playing back over your history of your activities and seeing where do things line up in terms of your communication, in terms of your analyzing the emotions and the sentiments correctly, and being able to make adjustments going forward. So another step here is to schedule upcoming activities. Now that you have history, recent history, as well as over time, even longer history, you now can start to deduce what things you want to do going forward. And if you watch the movie, you'll see a little bit of that when the android walks in and talks about, hey, I'm going to need your schedules, right, of everybody in the house, so I know how to respond and interact with people. And that's kind of an example of what I'm talking about, but it could just, expand beyond that, obviously. There are no limits. And then another bullet here is for updating your training and test data sets. You're constantly collecting information, so it makes total sense this is now good data, real-time data, relevant information that you can update your data set, especially if you come into new environments and meet new people, or if there are new players, new objects involved, that now a new audio, new things that are going to now be a kind of a primary part of the android's existence. You would want to train your data so they can know, you will know to update your data, I apologize, and train your models so that they can be able to perform optimally in this new environment. And that's where you get the fine-tuned AI models at the bottom. Okay, so again, here is like a comprehensive overview of how this can all come together. Obviously, there are other things that I did not discuss, and I will mention that briefly in my closing. In summary, this was a review of how to implement the android in the movie Subservience. The focus was on using current technology to mimic how a human hears and sees. What I did not go into are the other 3 senses, which are taste, smell, and touch. And I also did not discuss the low-level details of the machine learning, computer vision, and other technical areas. If you find this content interesting, give me a comment, give me a thumbs up, and I can discuss further along these lines, as well as go into other technologies in other areas. One area on tap is to talk about how different cultures impact AI applications today and in the future in regards to how they use conversational AI, generative AI, and beyond. Thank you again.